Hey guys, we're on to day 3 of our revision now for our dream assessment part 2. Today we're going to be having a look at differentiation and gradients. Let's have a look at the first slide here. Okay, so our inspiration for this topic was it's difficult to read, it's so small. I think that's question 14? Question 16. It's question 16 from the 2016 paper 4 of January. Differentiating an expression or a equation, like y equals 3x squared minus 12x plus 3. Really, it doesn't matter what this value is that's added on at the end, because when we differentiate, we take the power of the x, we multiply it up front, and then we subtract 1 from the power. But as there's no x here, we know that that one's just going to disappear directly. Okay, so differentiating this, find dy dx. We just take the power, multiply by 3, so 2 times 3 is 6, and then we take 1 away from the power, so 2 minus 1 is 1, which is why I just have an x here, no power of 2 at all. The second term, negative 12x, if you just have a term with an x in it, the power is 1. So we're going to multiply by 1, which does not change the value up front, but that becomes x to the power of 0, which is why your x disappears. Remember that your x is always losing 1 power when you differentiate. So x to the power of 2 just becomes x. Just x, the x disappears, and no x, the whole term disappears altogether. So this is correctly differentiated. And then it asks you to find the coordinate of the point on the curve C, where the gradient of the curve is 18. So you need to remember this, and that's why I've written these reminders here for you. dy dx is the gradient function. So we use it to find the gradient, or we use it when the gradient is given, because we can say dy dx is equal to the gradient. In this case, we're told that the gradient is 18, so we write dy dx is equal to 18, which is what this person did. They took the answer for dy dx, and they wrote 6x minus 12 equals 18, and then we're just solving that algebraically. Move the 12 from one side to the other. It was minus, now it's plus, so that's 6x equals 30. Take your 6 from that side, it was multiply, so now it's divide, so x is equal to 5. Most people got this far, but as you can see on the answer line, we need an x and y value to find the coordinate. Remember, the coordinate point on a curve is an x-coordinate and a y-coordinate. There are 2 values you need to find there, and make sure you get them in the right order as well. Alphabetical, x, then y. So once you find the x value, you're going to need to find y using the original formula. Don't bother putting this x value back into the dy dx formula, because that's just going to give you your gradient, which we already know would be 18. You can use that as a check if you like, but if you're trying to find y, you need to use the original formula, the one that says y equals. Seems pretty logical, right? So back up to the original formula up here, y equals 3x squared minus 12x plus 8. Rewriting that down here, when x is equal to 5, we replace the x's with 5, so they've got in brackets here, 3 brackets 5 squared minus 12 brackets 5 plus 8. Important thing to know, and this person did do it right, but some people do this in the wrong order. Order of operations say we do powers, or exponents, before we do multiplication. Don't think that this is 3 times 5, 15 squared. It's 5 squared, which is 25, and that number multiplied by 3 is 75. Then I got 12 times 5, 60, and 8. So 75 minus 60 plus 8 is 23. So we've got our x-coordinate is 5, our y-coordinate is 23. Okay, so that's a really good example to help you understand what's expected of you. Remember, we're preparing for an assessment here, which will take exam questions like these, so you need to be able to work to the highest possible level. All right, so let's go to the practice. So day 3, differentiation and gradients. For each of these questions, find the gradient to the curve at the given x value. So the gradient to the curve, remember, we're working out what dy dx is. We're differentiating this. And at the given x value, we'll substitute this value into the differentiated equation to work out what the gradient would be when x equals 1, when x equals 0, and so on. Okay? This one, you're going to need to remember it needs to be in the right format before you can differentiate. 1 over x is the same thing as 1 times x to the power of negative 1. Remember fractions? Maybe I should write that for you here. Remember that fractions, where there's an x on the bottom, can be written as x with a negative index. Negative indices. Reminder. Excuse me. So that means 1 over x to the power of, let's say, for example, 5, and I'm just going to show you how I can make that into a power. I can go up to, where is my format? Text. And I'm going to turn that into superscript. That's putting it up high. Okay, so 1 over x to the power of 5, copy. I just copied that so I wouldn't have to do it again, equals, oops, equals x to the power of 5. Now I'm going to make that a negative 5 up top there. Oops, again, minus 5 up top. Difficult to see when I've made it so small, but 1 over x to the power of 5 is equal to x to the power of negative 5. Okay, and you could, of course, change the size of your font if you want. Right, so this is going to be y equals x to the power of negative 1, and then you can use the normal format of, or the normal method of differentiating. Take the power. So in this case, I would take this power, multiply it out front, and divide by x. So if I actually make this a good example for you, y equals this. Again, I'm copying it all so I can paste it all down below, because that'll make it quicker for me and easier. Paste. So if y is equal to 1 over x to the power of 5, y is equal to x to the power of negative 5, you first need to get it into the right format, and I'll write dy dx then equals negative 5 multiplied out front, x to the power of, and I'm going to copy this over so I don't have to do that work with the superscript again. I take 1 away from negative 5. Now be careful. Taking a number away from a negative number makes it more negative. That's now negative 6. Okay, so there's an example of a fraction, which I first have to get into the right format, and then I've differentiated it. So you're going to have to do the same sort of thing with this one here, and then we'll substitute negative 1 into your differentiated answer and work out what the gradient is. Okay, then you're going to work out the equation of the tangent to the curve at the given x value. The equation of the tangent to the curve. Okay, let me write this little reminder for you as well. Equation for a tangent to a curve. That's an equation of a line. Equation of a line. So I'm going to write the equation of a line is y equals mx plus c. Y and I've already got the gradient. When I substitute in here, for example, let me say I want to write the equation of the line, so the gradient of the line, where x is equal to 1. X equals 1. Okay, so I'm going to substitute that in here to work out what my gradient will be. My gradient when x is equal to 1 would be negative 5 times 1 to the power of negative 6 minus 5 times 1. And again, I don't like to have to type this so many times, so I'm copying and I am pasting. And that's just going to end up being negative 5 times 1 over 1 to the power of 6. That's just going to be 1. So that's going to be negative 5. Gradient equals negative 5. So if our gradient is negative 5, now I'm going to go write down my equation of a line. It's going to be y equals negative 5x and I need to work out what c is. Now this is a tricky bit. We don't know what the y-intercept is, and we don't really have a way of figuring it out from the equation of the line, but we do have the x value. If we can find the y value, we substitute it in there, and we can work out what the y-intercept is. So given that x equals 1, let's work out what y is. Y would be equal to, from the original equation up here, 1 over x to the power of 5. I'm going to copy that and put that down here. Where x is 1. Right? Because we're saying when x is equal to 1, what's the y value? So that means that y is going to be equal to 1 divided by 1 to the power of 5. That's 1. Y equals 1. Okay, so I know that x is 1. When x is 1, y is 1. I can substitute that in here, and I can work out what the equation of this line is. When y is 1, x is also 1, so that's minus 5 brackets 1 plus c. So this is so that we can work out what the y-intercept is. So I'm going to work out what c is that makes, which c value makes this true. That's going to be 1 equals minus 5, because minus 5 times 1, plus c. To find out what c is, I need to rearrange, get c on its own. So I'm going to move the minus 5 to the other side. That's going to be 1 plus minus 5. Sorry, 1 plus 5. It was minus, now it's plus. Equals c. So c must be 6 then, right? C equals 6. And I can rewrite my equation of the line from up here. I knew what the equation of the line was. The only thing I was missing was what the c was. Now that I know c is 6, I can go ahead and write the equation of the line. I'm going to copy it from up here again, so I don't have to type the whole thing out. I just need to add in. Oops. I just have to substitute in copy the 6 for the c. Paste 6. Okay, so that's my equation for the tangent to the curve. That's the difficult bit. Now, also set as work for the day was to have a look at the differentiation worksheet that I posted on Schoology for you, specifically questions 5, 6, 7, and 16 for worded examples, which are more similar to the kinds of things that we saw in our example over here, and things that we might likely see on this assessment. So let's go over to this differentiation worksheet. And we said that we were going to have a look at questions 5, 6, 7, and 16. Is that right? Yeah. Okay. So just have a quick look through these. For the curve with the equation, this, find dy dx. Okay, differentiate. We've already explained. And B, find the value of x where dy dx is equal to 7. Okay, so pretty straightforward, just like the inspiration for today's work. We'll differentiate this. We'll set that value equal to 7, that if formula equal to 7, and then we'll work out what x is. Question 6, find the coordinates of the point of the curve with the equation this, at which the gradient of the curve is 4. So again, very similar, except for here, we're not just looking for the x value, we're looking for the coordinates, both the x value and the y value. So pretty much exactly like our inspiration question. Right, question 7, here you got the equation for the curve. You're told that the gradient of the curve at this one point, find the gradient of the curve at this one point. So again, to find the gradient of the curve, we differentiate. At this specific point, they've given us both an x and a y value here. We're only going to use the x value. So when x is equal to -1, we substitute that into dy dx to find out the gradient. And then the next part's a little bit more confusing. Given that the gradient at the point Q, that's a different point on the curve, is the same as the gradient at the point P, which is this point here, find the exact fractions, so not as decimals. We want to write it as fractions, so x is some fraction, y is some fraction. The coordinates of the point Q. Okay, so what that means is we need to work out, differentiate this, and using the gradient that we've got here, we're going to substitute it in. So we'll say that dy dx is equal to that gradient that we worked out in A, and we'll have a quadratic that we need to solve. There are two solutions to a quadratic. One of the solutions will be this point here because there's 2 points where the gradient is equal to what we worked out in A. One of them is when x is equal to -1. Find the other possible x value because that's the x coordinate for Q. Once you've got the x coordinate for Q by solving that quadratic, we'll substitute that x value into the original equation where we get the y value, and then you've got your xy coordinate for Q. Remember, we want to give our answer as an exact fraction. So if you see that you need to do something divided by something and you get a decimal, don't do the division, leave it as a fraction, one value over the other. Okay, and then our last question, question 16. Really quite a challenging one here, I think. Here we've got a straight line L, which is a tangent to this curve at some point A on the curve. Given that L is parallel to this line, find the coordinate of point A. So the first trick here is that we are trying to work out what the gradient of this line is. So you need to rearrange this line into the y equals mx plus c format. You want the y by itself, so send the 3x to the other side. Work out what the gradient is. Then use the gradient and dy dx of this curve, so differentiate this curve and set it equal to the gradient that you worked out from here. Okay, if you set up that equation, you can rearrange that equation and solve it, and you'll find the x value that makes that true. That'll give you the x coordinate for point A. You also need to find the y coordinate for point A, so using that x coordinate, substitute it into the original y equation and work out what y would be when x is the value you found. Right, that gives you point A. For question B, find the equation of the line L in the form y equals mx plus c. Now this is another really challenging one, like the one I just did for you on the slide. You just worked out what the gradient is from here, so we know what m is. You know a coordinate on the line, so an x and y value that go together, so we'll substitute the x value in here, the y value in there, and the only thing you don't know again is the c. So you'll rearrange that, you'll solve it, getting c by itself, you'll find c's value, and then remember to write your final answer as y equals the m value that you have from here, x plus the c value that you worked out, right? Y and x are still the letters y and x, m is the value that you found up here, and c is the value that you just worked out. Okay, now I know that today's work is really very challenging, and there's plenty of other examples that you can try from here. As you can see, there is loads of practice that you can get, but do not skip those hard questions that I just pointed out for you. If you don't know how to do them, you need to ask because you need to be able to do them for the assessment. Okay, so good luck with that, and I am expecting to hear from all of you at some point today.